There we go. Okay, to start, OpenStack from scratch. Why OpenStack is the complete first title of my first slide. And I put some reasons down on the sheet. Sorry. The main and biggest reason to choose OpenStack is because it has a very large user base. Lots of small companies to huge companies like the Alphabet Group are using OpenStack to power their private clouds. Many hardware vendors support it. I have seen VMware, Cisco switches, NetApp storage, many large enterprise hardware vendors support writing OpenStack drivers so that their products can be used within the OpenStack cloud product. Many automation vendors also support it, so you can use Terraform or Ansible or Puppet or whatever you like, and it will simply work with OpenStack. The same goes for many orchestration vendors, like OpenStack Heat, which is the built-in. Terraform will use it, Ansible. I think I have this one double, okay. OpenStack has a steady release cycle. It releases a new major version every 6 months, which is quite fast. Usually they are completely compatible to all the releases. And I think they take 5 previous releases. So that gives you 2.5 years of compatibility to older releases. And it is fully open source and free to use. You can simply download the software from the internet, install it on your computers, and it will work. However, the last part is not that easy as I have written it down here. The deployment of OpenStack, in fact, is so difficult that a number of companies and private people have started their own deployment software for OpenStack. One of them is Red Hat. They have developed the PackStack OpenStack deployment, which is mainly aimed at development users. Which is mainly aimed at development users and using small-scale lab test setups. PackStack isn't capable of performing on a high available or heavy network cloud environment. It is quickly limited in scale. Next deployment method is Puppet. Puppet is a mature deploy method. They have lots of classes that implement various OpenStack components, and they can configure quite a lot of OpenStack within the Puppet language. But like the PackStack method, Puppet is not capable of performing high availability OpenStack software. And Puppet is fairly complicated. So if you do not know Puppet, you will have to learn Puppet and able to use this deployment method. The next is Ansible. Ansible has all the advantages of the Puppet deployment method. The Ansible classes are better maintained than the Puppet ones. Even though that Puppet is a mature product, I have seen them fall behind lately, and Ansible keeps up with the current OpenStack releases. Ansible, however, also has the complexity of Puppet. If you do not know Ansible, it will be difficult to use it to deploy OpenStack. Ansible can be used to deploy high availability OpenStack, which basically means that Ansible can scale with your OpenStack environment once your needs start to surpass a single node or a few node environments. Next up is Coyote. Coyote is written by Stack HPC, which is a high-performance cloud company whose focus is solely on high-performance cloud software. They support OpenStack, and they have a very mature product to deploy OpenStack. They use the Ansible deployment method, but they hide all the ugly technical details below their Coyote software, which means that you basically use Ansible without having to know a lot about Ansible. Koyobi also utilizes the OpenStack Cola project, which means that you can use anything that can run Docker containers, can also use OpenStack services. You don't need to have a complete hardware host. You don't even need to have a VM. You can, for instance, deploy OpenStack on a Kubernetes cluster because it supports Docker containers. Of course, why you would want to is another question, because that is a very complex situation. Koyobi has one advantage over the rest, and it is very easy to configure. And oh, the wrong mouse. It is very easy to configure, and therefore I have chosen this as my deployment method. My deployment method of OpenStack on Koyobi turned out to be a good one. It took me about 4 months to learn Koyobi to a sufficient level to start deploying my own private cloud. The most difficult part of it was getting the networking right, because as I have stated in the sales pitch, I would like to say, of this meeting, this event, that most of the examples deal with one node all-in-one deployments of OpenStack, which means all the services run on one node only, one VM or one hardware host. It matters little, it is just one. Koyobi supports more than one host. In fact, if you deploy more than one host, it automatically enables high availability between the services. So you don't even have to configure it. It is out of the box ready for high available use. Koyobi also deploys all OpenStack services as Docker containers. So if one of the containers goes down for whatever reason, Docker will spin up a new container, and OpenStack will remain available as all the services you need. Koyobi is also very easy to deploy OpenStack in production environments. Once you set up the hardware, you set up the nodes so that they can receive the OpenStack software, you can use Koyobi to deploy OpenStack, and it will install a production environment, which means automatic high availability when you choose more than one node for instance, as compute instance. It will automatically turn on that if a node crashes and restarts, that all the virtual machines it was running will already restart with it. And all other things that do not come out of the box with OpenStack are turned on where it makes sense. Well, like I said before, Koyobi uses Ansible, and it in detail uses the Cola Ansible project to deploy OpenStack. Cola Ansible makes sure that all OpenStack services like Nova and Neutron and all the rest are deployed as the Docker containers. And if I answer my own question earlier, why you would want to run OpenStack services on Kubernetes, is because Kubernetes quite easily scales up and down as needed when services start to become overrun with requests. So Nova becomes unresponsive because the node that runs the Nova services get too many requests. Then the Kubernetes cluster will say, okay, I'll just spin up a new Docker container running the OpenStack Nova service. But this is the next step, basically. Koyobi does not do that. It just deploys plain Docker containers. Koyobi, finally, also follows the OpenStack command line guidelines. So if you are used working with the OpenStack CLI commands from the OpenStack Python client, then you can use Koyobi commands because they follow the same principle. You start with the command, then the options, and the exact same sequence when according to all the other OpenStack components. Okay, then Koyobi setup. Koyobi is the setup in three mandatory and 2 optional parts. The first mandatory part is the deploy host. The deploy host will have Ansible installed because that is a prerequisite of running Koyobi. The deploy host Also has to be able to log in without passwords to all of the nodes that will start to run your OpenStack production cloud. The second is the seed hypervisor, which is optional. The seed hypervisor's only task is to run the seed, and its only requirement is that it can reach your OpenStack nodes on the network that is used to deploy OpenStack. The seed is also optional. It only runs on the seed hypervisor, and its main function is that if you have an air-gapped network or some other network that is unable to reach the internet, then the seed will take over the function of the internet for purposes of installing OpenStack through Koyobi. Koyobi also assumes you have at least one control node, one compute node, and one storage node in OpenStack. But I've managed to trick it to run the storage and compute node on the same hardware node. So that's of course not a production-ready environment, and you will run into performance problems if you do that, but technically it worked. Right now, my own private cloud is hosted in a data center in Almere, which is my hometown, and it consists of 2 control nodes, 2 compute nodes, and 1 storage node. Well, to dive a little bit deeper into the deploy host, like I said, the deploy host has Ansible installed. Ansible is automation software that runs basically on all hosts that are in an inventory file, and you can automate the tasks you want to do on all the hosts that are in the inventory file. It uses the pip installer to download the configuration framework you need to properly configure Koyobi. The Koyobi config is also a public Git repository on GitHub if pip is unavailable to you. Most Red Hat hosts have pip installed or pre-installed. The seed, hypervisor, and the seed. Well, like I said before, the seed only runs on the seed hypervisor, and they are both completely optional. They only are mandatory when you do not have access to the internet on your deploy host. The OpenStack environment itself does not need internet access. Only the deploy host does. And if they don't, then you can prepare the seed, and the seed will act as the download for the OpenStack hosts. Also, the deploy host can act as the seed when a separate seed is not deployed. This means that you will need to resize your deploy host to quite a few hardware requirements, or of course a virtual machine with lots of RAM and CPU power. The seed cannot run on the overcloud, but the deploy host can run on the overcloud. Now, what is the overcloud? I can already hear the question, so next sheet. OpenStack has defined a production cloud named overcloud and a deploy method named undercloud. Koyobi follows the same naming convention, but it does not deploy the undercloud because it is the install method. It does not need an undercloud, it only deploys the overcloud. In all the commands that you type for Koyobi, you will see the word overcloud, and now you know why that word is there. All overcloud OpenStack nodes can deploy on both virtual machines and on hardware nodes. It does not matter. The only thing that it needs is the ability to run Docker containers. So anything that can run a Docker container can be an OpenStack node. So let's dive a little bit deeper into the Koyobi configuration. Because the space on my presentation sheets is a bit limited, I have renamed Koyobi_home to KH in these slides. Right. KH the Koyobi home can be done through a pip install or a git checkout of the Koyobi config directory on GitHub. It will create many files, one of them being Koyobi config etc Koyobi inventory hosts. This file is completely empty when you check it from the internet, but it is complete. with lots of comments on what you should put where. So let's take an example of that. This is a very basic inventory file. As you can see, I have put down a host named deploy.linuxfriendly.nl as the seed, which also happens to be my deploy host. So in my case, my deploy host and my seed are one and the same machine. I found out later that I do not even need a seed because all of my hosts can directly connect to the internet. I've decided to put in two control nodes dedicated, control 1 and control 2, and one of the compute nodes runs control 3 as well. So I always have at least two control nodes available if one goes down. Well, the compute nodes can be guessed from the above naming conventions. They are compute 1 until compute 3. And of course, there is a storage node, which is with the label storage, and there is only one storage node. Okay, now, of course, all of these software will need to know how to connect to the different hosts. So one of the most, yes, sorry, someone entered. So one of the most important parts is defining all the Ethernet interfaces of how the cloud operates on your private cloud. Right, there we go. So there is a few, I have a question from Willem Deal who says he does not hear anything anymore. Ah, it is better now. Okay. I have defined 4 networks in my Kyobi config named control, 4 letters CTRL. I have named a tenant, which will host the virtual machine network Ethernets. I have a storage network and I have a backup network. Purely the fact that I can define these different networks means that you can already see how Kyobi will scale your network. My control interface is named control. And my control bridge port is named A01, which is the first Ethernet card of my machine. Then I have a tenant interface named tenant with a bridge port A03. It is unfortunately a little bit under the page numbering, but A03 is of course the third Ethernet card in my machine. So how does Kyobi know what your networks are named? This is defined in the file networks.yml. So it will have a bunch of entries, and behind it you would need to type the name of your network. So it has an admin overcloud net name named control, a provision overcloud net name named control, a provision net name named control. It will also have a storage net name, which will be named storage, a tenant net name, which will be named tenant. And then after you have defined all the variables, you can give them values. So my control IP address range is 10.11.0.0. My gateway is .0.254. And this is the important part, the VIP address. As I said before, Kyobi will always deploy high available services, so it will need a VIP address on some of the networks you define. Those networks are the control and the tenant networks. The storage network will not have a VIP address, and the backup network also will not have a VIP address. Finally, again through the page numbering, the control physical network is VSNet1. This is the name defined within OpenStack if you want a VM to be part of this network. So if I want to have a virtual machine directly on my control network of 10.11, I will have to assign it in the VSNet1 network within OpenStack. Coyote also comes with some extras. These are always installed when you have more than one node defined, which is a high available Elasticsearch cluster. It will have a minimum of 3 nodes. So as long as you have a minimum of 3 nodes in your inventory file, it will automatically deploy an Elasticsearch cluster. The same goes for an HA proxy cluster, a MySQL/Galera database cluster, and a RabbitMQ message cluster. They all will use the VIP address you defined in the previous slide. The HA proxy status page is also a very handy page to have. It will run on port 1984, which is a nice reference to a very old book written in 1948. It is basically the page that will show you if all your services are up and available, and it will turn red if some of your services are not available before your customers start to complain, because the VIP will simply be taken over by one of your other nodes. And you won't see it by watching the VIP address, but you will see it if you watch this status page, because you will see one of the backends going down if it goes down. Coyote also has add-ons which are not installed by default, but they are very easy to add on. I have found it very easy to simply run the Coyote installer again, and then change the setup of your cloud when needed. For instance, I did not want an Elasticsearch cluster. I wanted a Grafana cluster with collected behind it, and this was very easy to change. I also found out that my OpenStack nodes had a timeout of only 60 seconds when trying to create a hard drive of 40 gigabytes. This was a bit on the short side, so I extended it to 600 seconds. Also, the inventory files and all the other Coyote configuration files are very easy to extend to create any kind of customization you would like. But this, of course, takes a hit on the scaling of OpenStack. The more custom software you have, the more difficult it will be to make it larger once it is deployed. Coyote also has many add-ons for management software for easily monitoring your overcloud. It has CloudKitty, so you can charge your customers money. It has Grafana and Prometheus to start alerting when stuff goes down. It has HA proxy, I already said, the status pages. It even has a web page where you can watch the OpenStack message queue software called RabbitMQ. And you can see if queues are available, if messages start stacking up because some software went down. So, yeah, very enterprise ready, in my opinion. Okay. And screen sharing has stopped. Okay. I see already. I have reached the end of my presentation. A bit on the early side because I see we have until 9. So if you have any questions about what, or if you were late and you would like to see some slides again, we have many extra time.
Do you have some sort of demonstration that you can show, maybe? Maybe some pics from the actual cluster?
Yes, I have a demonstration. Work. Login. not. Okay. Mhm.
Can I ask another question in the meantime, or?
Yeah, sure.
Okay. You chose Kobe, you said, but you do need some sort of Linux underground, I guess, because there's a pip install thing.
Yes.
Yeah. Well, I'll be honest. I'm from the Windows, realm of users, admins. Any Linux underlayer you would advise for Kobe?
Yes, Red Hat works well and Debian works well.
Oh,
Any
DB.
others
Okay.
I would not advise unless you know quite a bit about Linux.
Yeah. Yeah, those are pretty much ready to go.
Of course, for people who know fairly little about Linux or nothing at all, Ubuntu will also work because it is based on Debian and it comes with a nice graphical user interface you will probably be used to.
Yeah. Oh, that's a good one. Yeah, I'll remember that.
Why? Is it gone? There it is. We have two people who would like to join. Mouse, there we are. Almost ready. Yes, there we go. See if I can make the font a little bit smaller. Right. Okay, there we go. I have asked OpenStack installed on my private cloud to show me all nodes connected to my OpenStack environment. Well, as you can see, I have a few compute hosts, I have a few schedulers, I have a few conductors. And if I say,
What is a conductor, Mark? I missed that one.
conductor basically says, if I schedule a virtual machine, it asks all OpenStack hypervisors, how much machines do you have and how much space you have available for new machines? And then it chooses the best fit for the new machine. It is also based on the storage that an hypervisor connected to the same LAN as the storage will be preferred over one that has more RAM available, but has a weaker link between the storage and the hypervisor.
Okay, thanks.
So now I have switched to one of my clients named Sander van Vught. He runs virtual machines on my production cloud, and he asked me to host his classrooms. When he's teaching Linux or Kubernetes or whatever, he will tell me, please, can I have a few virtual machines? Well, these virtual machines have all been deployed on the cluster. Right now, I see I have about 36 actives and 12. And one of the hopper hosts is for some reason. Well, it's his class. I'm not going to touch his host, obviously, because then he will call me and he will be very angry. But basically, I think he is teaching tonight. I think he's, from the look of the state of the VMs, he is teaching a Kubernetes class, and he needs 3 virtual machines for each student. They are connected to a classroom network defined in OpenStack, and there is no image available. So I don't know what operating systems they are running, but they will, of course, be operating systems ready to host Kubernetes on it. Let's see. If I do a project list, you can see a few other clients that are hosting environments on OpenStack. Sander has one. Then I name to his project. It shows a very long UUID. I have a web hosting, which is basically my own internal OpenStack for website hosting. Some people will not like complete virtual machines, they want just a website. And I use that OpenStack project to host them. Admin is mandatory. Admin project runs all the routers connecting my OpenStack to the internet. IT Guild is running virtual machines. I have a service and an infra project. They are also mandatory. I have another Linux trainer, Frederik Vos, and I have my own projects, which is basically what you're seeing now, the interface. I've logged on to my own virtual machine, and I'm sharing its screen over the internet while it is running on the OpenStack, which is quite nice, and the performance, as you can see, is very, very nice. Well, it has to be, because people pay me good money, and all I hear is that they are satisfied with my service. Now, if I go to my OpenStack.
Mark, there's someone in the lobby wants to just join in.
Is there somebody in the lobby? Yes, I see it. Let us join them. I was busy typing. I did not see it immediately. Looks like it is working. He is joining. Right. So. Wrong user. Yes. This host is the Coyote host, which I use to deploy the OpenStack environment After the OpenStack was up and running, I shut down the virtual machine that was running on my laptop, and then I moved its hard drive to the OpenStack environment and rebooted it. And right now it is happily running. My deploy host is happily running on the OpenStack it itself deployed. Should it ever start to break down, I will have a chicken and the egg problem, because in order to redeploy it, I will need access to this host, which is running on the own OpenStack environment. But I'm confident that will not happen. So this is the project, Coyote config, which you can get from the internet. It has a nice setup utility, so you don't need to start from scratch, basically. Here I have the networks defined again, but then as you can see, everything is commented by the Coyote guys, so you don't need to guess what everything is for. You can read in the comments what every network name is and what it is used for by the Coyote software. I actually quite like it. Now you have a tenant network for the virtual machines, control network, which sends the control traffic like OpenStack compute host wants to communicate with the controller. That is done on the control network. The control network uses different Ethernet ports than the tenant network. And the tenant network is reserved for VMs only. So any VM that wants to communicate uses the VM network. I have a question from Karim. What is the GitHub repo link? I will share that in the chat. 1 second. Do it like that. And yes. No, I don't need to do it from this. Yes. Off. Zoom. Okay, I have shared on the Slack Zoom on the Zoom chat the URL to the GitHub repo link. The Coyote software I will also share because it is a different one, but it is not. I forgot that in my sheets, but Coyote is an official OpenStack project, just like Nova and Neutron and all the other ones, which makes it one of the official ways to install OpenStack. Yeah. CCHI.
Was a good choice then.
Yes, it is. I was quite happy with it. Okay. I've also shared the link to the Coyote software, which you will need to deploy the configuration files. So let me put it back to full screen now. Yes. Okay. Back to this keyboard also. And to load. People entered the waiting room. Right. So, as you can see, all networks have a name within Coyote and a name within OpenStack, which can be confusing. So the external net names are the net names that Coyote uses to communicate in its configuration. And the internal net names are the names that OpenStack itself uses. Where is my chat? Where the hell? Ah, here it is. I had a question from Flores if you can install OpenStack just to test it on a few virtual machines. And the answer is, of course, yes, you can install it on anything that will support Docker containers. The deploy host is the only exception to it. It will need to run Linux, and it will need to have Ansible and Python available. Okay, so here I have defined all the names I will use for my OpenStack cloud environment. I have a question from Willem Deal, which is basically just a comment to me, which is very nice. I will surely keep that in mind when presenting again.
Hey, Mark, thanks for sharing. I have to go. I need to eat and then to the next meeting.
Okay.
Thanks a lot. And see you later.
See you later.
Bye.
Bye. As I was explaining, now that we have named all the networks, you will start the network name and then an underscore and then something you wish to define about this network, which is all explained in the Coyote documentation. For instance, you will need to define a network range that belongs to the network, the gateway of the network, the VIP address that OpenStack will use to make all its services highly available, and the physical network name that OpenStack will use if you want to deploy virtual machines on OpenStack and you want to connect them to these networks. As you can see, I've deployed 3 networks. The backup net is not yet in use, but I only have control, tenant, and storage networks. Currently, I do not need the backup network because my storage network is more than fast enough to also have the backup traffic on it. Also, to make sure that the storage network is not overwhelmed, I have connected the storage network with 10 gigabit Ethernet cards, and the control and virtual machine networks are 1 gigabit. And it is all performing quite nicely. These are all examples, and they all contain all the possible variations of things that you can enter in the configuration. As you can see from the comments, you can also put start and end DHCP ranges. You can assign an FQDN so that all machines that are built in a certain network will all automatically have those FQDN extensions. There is very much possible with Coyote. You can even, for hosts that have custom interfaces, you can even handpick what the network bridges must be named so that the Coyote can find them if a host has been installed not according to the other configuration items. So if I'm going to look then in inventory, which basically contains all your hosts that Coyote can find. It will not contain a hosts file, but it will contain a hosts.example file. You simply copy it to hosts and then edit it according to your needs. All the groups, let me edit that. You can have groups, and basically groups, this is the high overview groups, and it basically says, if I have Prometheus hosts defined, they should go into the group monitoring. And if I have management switches, they should go into switches. And so all the Coyote groups are linked to the OpenStack groups, so Coyote knows what to enter. I'm now, if I go to the groups vars directory, which is basically an group vars directory, which is how Ansible works, you can override certain groups which you have named. For instance, I wish to have certain variables that only apply to compute nodes. I can put them in group vars compute. And the only thing right now I wish to override are the network interfaces of my compute nodes. So all my compute nodes will have a control bridge, and it has a network interface named Eno1, and it has a tenant bridge that have bridge port Eno3. As you can see, there is no storage network defined here because there are compute hosts. So if I go to my storage group, and I look again in the network interfaces, you will see it also has a control net because it needs to control the control net to communicate with the other OpenStack nodes, and it has a storage net. And the storage is defined on Eno2. So all hosts that have storage capabilities has a network name, second Ethernet card connected to the storage net. The storage net will use iSCSI drivers by default to export all the hard drives. OpenStack and Coyote are also capable of using NFS shares from, say, Data OnTap, S3 buckets on Amazon or anything else to have hard drives available to the virtual machines. But by default, they use the iSCSI protocol. It is a fast and reliable protocol, and it runs on the storage net if you have it defined. Now, if a network is missing, Coyote will warn you before you can actually deploy your hosts. So if I go back to the groups now, hosts, example, this is basically the example. And as you can see, it is completely empty. All you have to define, which are mandatory, are controllers. OpenStack will not work without controllers. But if you do not define any compute or any storage or any other nodes, then controllers will take over those roles. So if you have defined only compute and only controllers, then any storage provision will also run on your controllers. There is an extra group here named bare metal compute. Bare metal compute are basically Linux hosts running on real hardware that is controlled by Coyote. So you do not need to install Linux on those. Coyote will take care of that for you. It will also install, I think, Red Hat on it, or CentOS, or Rocky Linux, or anything else Red Hat compatible. And it will use IPME to make sure that the host boots when it is needed to reboot it and everything else. As you can see, you can also have switches defined in the Coyote configuration. If you have managed switches, like for example, Cisco switches, Coyote can also control those and provision the network that Coyote expects. So for instance, if you have defined a tenant VLAN on VLAN 11 with some network range, then Coyote will actively log into your Cisco switch, define the ports on which your OpenStack is defined, and assign them to VLAN 11, which is actually quite nice. So Coyote can take care of all of that for you. Now, if we dive a little bit deeper into the cola.yml. The cola.yml file basically defines which parts of OpenStack you want to make active and on which nodes. It also has some of them set by default, so even though they are not active, you can see that they are enabled by default. As you can see, my own OpenStack environment does not define a whole lot of services because I don't need them. But the ones that I do define out of the box is Elasticsearch. But I didn't want Elasticsearch, I wanted Grafana and Collected, so I disabled Elasticsearch. And as you can see, there are hundreds of projects enabled or disabled, and you can simply enable them, rerun Coyote, and then Coyote will install it for you and reboot all your nodes one by one so that nothing is touched for customers. Customers will never notice any downtime when you reboot or enable Cola again. Now, if you have custom passwords that are defined somewhere, you can also add them to this file, and Coyote will then use them. For instance, if you have, if you need a password to become the root user on Linux, the so-called sudo password, then you can also define that in this file. Once Coyote is finished, it will make a new file. Oh, I think it is here. Yes, this file is named passwords.yml. It will contain all the passwords you need to control your OpenStack environment. Now, as you can see, it is multiple pages of texts, all containing very, very, very long passwords. So once your OpenStack is up and running and you think, oh, geez, I forgot to write down my password, you can find it in this file. For security reasons, of course, the file is owned by Stack and it is renamed to rights of Stack only. So no other user can touch this file, except I was less secure and I renamed it to have more rights, because I was toying with Ansible and was unsure how Ansible would react if the file was set to 600. Of course, it all worked perfectly, but I'm still learning Ansible. So that's why my file is not right 600. I talked a little bit about OpenStack being deployed on real hardware nodes controlled by Coyote. Coyote manages this with the Bifrost project of OpenStack. The wrong directory again. That's one of the things that took me a while to learn. Coyote has lots of directories that look alike. So you need to know what directory you are in order to see the files. So Bifrost controls your hardware hosts if you do not want to install, or if you cannot install Linux on your hardware yourself, but you need Coyote to take care of that. For instance, if you have an OpenStack size of 1000 hypervisors, you do not want to install Linux on those all by yourself. You want Coyote to take care of it. And then you will define them in the hardware host group, and it will use Bifrost to install Linux on it before starting the OpenStack installs. Well, that basically is the very short runaround of Coyote. Floris, is your question answered now?
Yeah, it's answered. Thank you.
Okay. Any more questions?
Very nice walkthrough.
Mhm.
There's one more question from MJ Wright. What interface is required between Docker and VMs? I don't know if you
Yeah,
answered that.
Michael. The interface is basically the standard Docker 0 interface. It will be created by Coyote, and Coyote will also take care of installing and configuring the Docker daemon for you on your Red Hat hosts or your Debian host. So you don't need to take care of that yourself. Basically, Coyote is a do-it-all solution. Unless you want to do it yourself, Coyote can take care of it for you. I don't understand the question really. Which VMs, the virtual machines that will be used to install OpenStack on? Basically, Coyote starts with a bunch of hosts. One of them is the deploy host. It will run Ansible to deploy OpenStack on the other hosts. And the other host basically is anything that can run a Docker container can be an OpenStack host. I think Flores asked the question if that can be a virtual machine. So the answer to that would be yes, it can be a virtual machine. All you need to do is make sure that Coyote knows which network interfaces correspond with the OpenStack network interfaces. Of course, if your virtual machine has only one interface, network interface, I mean, then you will simply define ENO1 or ETH0 for all of them, which makes setup quite a bit easier. You set up one interface in the overall environment, and then all the children will think, it's that interface. Yes, this is correct, Michael. Docker is only used for the control plane, and the virtual machines do not know Docker exists. Only OpenStack does know that. Samir asks if Coyote is the only choice or if there are alternatives. This is basically what I explained in my sheet. Let me get back to it. Just need to stop sharing. Minimize the sheet. Where is the sheet? This one. Now I'm going to right. I have put back my sheet. The deployment methods are first Packstack. Packstack's biggest pro is that it is easy to use. It has one big answer file, but Packstack quickly limits your scale. Packstack only has one Ethernet interface for all your services. So your tenants, your storage, your control network are all running on the same Ethernet interface. PackStack is mainly aimed at development of OpenStack itself and small-scale setups. PackStack also is not capable of high availability. Okay, next deployment method. Yes, the next deployment method is Puppet. Puppet is a mature deployment method. Puppet basically is a bunch of Puppet classes, and therefore Puppet is also complicated. You must be able to speak Puppet language in order to deploy OpenStack with it. The same goes basically for Ansible as a deployment method. Ansible is also quite a mature product. It has all the advantages Puppet also has, but Ansible, I think, is better maintained. It follows the OpenStack release cycle closer, and the fault finding, so to speak, is more complex and better and more complete. So if you do something wrong, Ansible will easier give you a meaningful error than the Puppet classes. Gabor says thank you. Yes, thank you, Gabor, also for attending. And well, hopefully you will have more questions later. I'm also available for questions after the meeting, but I will soon go on a 3-week vacation. So I will have what's called a guru class later in September to have questions and actually host a demo of installing your own OpenStack environment as a bit of a small classroom. And at the end of this classroom, you'll have a good chance of running your own OpenStack. But this will all be after my vacation. Ansible can, meanwhile, the other question was about deploy methods. Ansible can deploy high availability, but it is also quite complex because you must know Ansible in order to use it. Coyote is basically built on Ansible. It hides all the ugly technical details of Ansible, and then you can use the simple Coyote language to basically interface with Ansible, which will deploy OpenStack for you. Okay, bye Michael, and see you next time. Coyote also utilizes the OpenStack Collab project, so it will deploy all OpenStack services as Docker containers. And I think that was also the last deployment. Yes, therefore, after I chose Coyote as my deploy method, because it is easy to use, but it has the power of Ansible. Any more questions?
Hi, Mark. I've got one question, and it has to do with how you're adding the nodes. So I saw those in the the presentation that you showed. There was a host file there where there were nodes. Are you supposed to how are the nodes are communicating? Are you using Ansible or any Coyote specific implementation?
Back to the host file. This is the host file. Or did you mean the one with the comments in it? Nodes.
Okay, that same one where you've got your nodes are defined, but then how are the how's Coyote able to communicate from the control plane to the other nodes?
It's, oh, let me stop the presentation then and go back to the other screen, which is this one. Oh. Yes. Okay, let's go back to my deploy host. Here is my hosts.yml. It is okay. Network. No, it is not. It is not. I know which. You are right. Good question. I skipped that part. There is also a file which was not yet shown, which is the network allocation. The network allocation basically tells Coyote which node is reachable on which IP address. Of course, this was one of my test nodes. I gave all of my nodes a unique name based on Greek mythology, so I could easily identify them. Of course, Coyote will not use the host names. The host names are only for us humans. Coyote will also always use the IP addresses associated to the host names. Host names also need to be resolvable by DNS, but to my best knowledge, Coyote does not use them, which is a shame because you already have a DNS. I also have a question from Samir. If Terraform can be used. Terraform can be used on OpenStack itself. So if you want to deploy virtual machines, networks, and everything with Terraform on OpenStack, that can be done. I'm not sure if Coyote itself can be controlled from Terraform. The question about the Coyote deployment IPs answered.
Okay, yeah, it has been answered. But one more thing that I also wanted to know was on the part where it's provisioning other services on the nodes that you add to the network. How is it able to log into those servers? Is it using Ansible or there's something else that Coyote uses?
No, it uses the Ansible credentials. So before you will start, basically you have two choices before you start. Either you install Linux on them yourself and you set up a user that Ansible can use to log into the nodes, or you will use the hardware Bifrost option, in which case Coyote will install your hardware node by booting it from a network Pixie boot, and then installing Linux and setting up the user for you. The latter option is of course very much preferred if you have thousands of hosts and you do not want to install Linux on them for yourself on all those hosts. But if you have a small environment, I think it is faster to simply install Linux yourself, add the user so that Coyote can use Ansible to connect, and then go from there.
All right, thanks a lot. That is well answered.
Also can be. I did have. In my demo, I did have, I think, somewhere a Terraform. Yes, I have here an example of Terraform scripts that create the classrooms that Sander van Vught uses, which we saw earlier. So if I say apply now, plan. So if I say I want to plan the new classroom that I've written with my Terraform scripts, it will now interface with OpenStack and it will find out that all of my OpenStack classroom already exists. And it will tell me it will remove 6 VMs because 2 students joined later and I deployed those by hand and not by this Terraform script. I go back up. See, it will say that some of the deployments will be destroyed because they were late addition students that were not planned originally. And of course, no trainer will tell you, oh, sorry, student, we are full, when you have something as powerful as Terraform at your fingertips. So the OpenStack environment deployed by Coyote is Terraform compatible. It is Ansible compatible. It is basically very nice. At least I think so. I have not yet encountered any limits, and I'm still growing very fast. Any more questions? I also hope that Christopher was paying attention when I showed how OpenStack is responding to Terraform, because he has a Terraform tech talk next week, I think.
Yeah. Yeah, I've paid enough attention, I think. So
No more questions for today? Okay, then I'm going to stop the screen sharing. And then we will see. Okay, then everyone, thanks for attending. And I will see Christopher at least next week because I will be attending his Terraform tech talk. It will be very short before my own vacation, so I hope I can make it. Otherwise, I will be sure to watch the recording later.